Hi friends, I am Sunil working as bsnl JE. Welcome to bsnl JE 2016 exam preparation classes. In this video, I am going to discuss electrical specialization topics. It is choppers. Chopper is a power electronic device which converts fixed DC to variable DC. Fixed DC supply to variable DC supply. They are nothing. That means they are nothing but DC to DC converters. DC to DC converters. Choppers are nothing but DC to DC converters. Chopper is a power electronic device which converts fixed DC supply to variable DC supply. Fixed DC supply to variable DC supply. Coming to this chopper, the chopper provides controlled DC supply by switching on and off at regular intervals. I will explain this chopper circuit phenomena clearly. That is, in the realization of chopper, it is supply voltage, fixed DC supply voltage. Here it is the output. For giving input signal, I'll explain. It is a fixed DC supply voltage. Here it is a V0 output voltage. Fixed DC supply. From here, when the switch is closed, the output is, the supply voltage comes to the output. When the switch is closed from here to here, then there is a output. And when switch is open, there is no output. When switch is closed, then there is a output. When switch is open, there is no output. And switch is closed, there is a output. That means by varying this switching on and off at regular intervals, we can get fixed DC to variable DC. Fixed DC, this is constant DC to variable DC. In this way, choppers are working. Here the switch is a mechanical switch. In case of choppers, chopper is used for the conversion. Okay. Once again, when the switch is closed, the input comes to the output. When switch is open, there is no connection between voltage supply and load. Then there is a zero output. For switch is closed, there is a output. Output is equal to Vs, supply voltage. So by using this mechanical switch, the output voltage can be controlled by varying the turning on and turning off of the time of the switch. It is a turning on time, it is a turn off time, it is a turn on time, it is a turn off time, it is a turn on time, this is turn off time. Total is T, total time. Okay. Due to limitation in the speed of mechanical switch, by using this mechanical switch, we cannot switching on and off at very high speed. So due to this limitation of speed, these switches are replaced by power electronic switch. Mechanical switches are replaced by power electronic switch. That is nothing but chopper. There are mainly two types of chopper: step down chopper and step up chopper. Step down chopper is the output voltage is less than supply voltage. The output voltage, step up means the output voltage is greater than the supply voltage. Okay. Two types of choppers: step down and step up. The choppers are nothing but DC transformers. Step down chopper. Coming to step down chopper, here it is a power electronic switch, nothing but chopper, and it is a diode, and it is load, and we have given supply, DC supply. For this, whenever the switch is on condition, we can get the output. That means whenever switch closes, the supply voltage goes from here to here, that is output. So output is same as input. when the switch is off condition, that is this is switch off condition. When the switch is in off condition, the output is 0, and whenever the switch is closes, the output is equal to the supply voltage. In this way, fixed DC, this is a fixed DC voltage. Fixed DC to we can get the variable DC voltage and variable DC current. For this step down chopper, the inductor is load side. The inductor is in load side. In case of step up chopper, the inductor is source side. Inductor is source side for step up chopper. Once again, step down chopper, for this is the input supply voltage. Whenever the switch is closed, the output voltage is same as that of input voltage. Whenever switch is open, the output is 0. Whenever switch is closed, the output is same as the supply voltage. In this way, we can get the variable DC voltage by turning on and turning off variations. And coming to the output voltage of this step down chopper, V naught equal to Vs into turn on by total time. T on is turning on time, T is total time. T equal to T on plus T off. That is V naught equal to alpha into Vs. Alpha into Vs means alpha is nothing but T on by T. That is alpha is nothing but duty cycle. It is a ratio of on time to total time. And V naught equal to Vs into frequency. Frequency equal to 1 by T. That means alpha equal to T on by T. That means alpha equal to T on into F. So in place of alpha, we can substitute T on into F. That is V naught equal to Vs into F into T on. These formulas, output voltage formulas, are very, very important. And alpha is also very important. Duty cycle, alpha equal to T on by T. And V naught RMS. RMS output voltage is root of alpha into Vs. We know that alpha is T on by T. And always V RMS is greater than V naught. And coming to the ripple factor is VAC by VDC. That is nothing but root of 1 minus alpha by alpha. Ripple factor is root of 1 minus alpha by alpha. And form factor VRMS by V average. That is 1 by root alpha. Form factor equal to 1 by root alpha. And total time T equal to T on plus T off. So turning off of chopper equal to T total time T minus T on. T minus T on means we know that alpha equal to T on by T. So from this, T on equal to alpha into T. Substitute in the place of T on, T minus alpha T, that equal to 1 minus alpha into T. That is T on is alpha T, T off is 1 minus alpha T. Very, very important bits. The problems he has given duty cycle alpha and total time T. Find out the turning on time or find out the turning off time. And output voltage of the chopper can be controlled by two methods. Output voltage of this chopper can be controlled by two methods. They are pulse width modulation and frequency modulation. In case of pulse width modulation, turn on time of chopper is getting varied. And frequency is constant. For this, frequency is constant and turn on time is varies. In this way, the chopper can be controlled. For this frequency modulation, turn on time is constant and frequency is variable. Then chopping frequency is getting varied and while maintaining the turn on time as constant. For pulse width modulation, frequency is kept constant, turn on is varies, and frequency modulation turn on time is constant and frequency is variable. Next one, step up chopper. Here the inductor is connected to source side. This inductor produces an extra voltage. This inductor produces an extra voltage to make the output voltage greater than the input voltage. It gives an extra voltage to get the output voltage greater than the input voltage. Here the first step up voltage means output voltage is greater than the input voltage. It is a step up chopper. In case of step down chopper, for step down chopper, output voltage is always less than supply voltage. Okay, here the inductor produces extra voltage in support to supply to make output voltage is greater than the supply voltage, that is V0 is greater than Vs. During this turn on time, the inductor works as a, in case of during turn on time, the inductor stores the energy. And it delivers the same when the turn off time, when during the turn off time. That means to get the V0 is greater than Vs, that means output voltage is greater than the supply voltage. The inductor stores the energy in turn on time and it will release turn off time. So that's why it supports the output voltage to get the more voltage than the input voltage. Okay, that means during turn on time, inductor stores energy, it delivers the same during turn off time to get the V0 is greater than Vs. And V0 here, V0 equal to Vs by 1 minus alpha. In case of step down chopper, V0 equal to alpha Vs, alpha into Vs. Here for step up, V0 equal to Vs by 1 minus alpha. And this step up chopper works in second quadrant. In case of step down chopper, works in first quadrant. That means step down first quadrant, step up second quadrant. I will explain this later. Classification of this chopper. Coming to this classification of chopper, there are mainly type A, type B, and two quadrant type A and two quadrant type B. That means first quadrant, second quadrant, and two quadrant, and then type E chopper. Coming to the first chopper, first quadrant or type A chopper. For this, this is a first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant. In this first quadrant, the chopper output is likewise. That is V0 output voltage. V0 is positive and the I0 is also positive. Here minus I0, it is minus V0. So the output voltage is positive and current is also positive. So the total power equal to V into I. Both are positive. That means power is also positive. Both are positive means power is also positive. For type A chopper, output power is always positive. That means power flows from source to load. That means it is motoring operation. So that's why type A chopper is suitable for motoring applications. That means motor receives a power. So in case of motors, power flows from source to load. And this step down chopper operates in first quadrants. Very important. Step down chopper operates in first quadrant, and step up chopper operates in second quadrant. I will explain here. This is the type B chopper. It is supply voltage and it is the load, RLE load, and this is the quadrant. In case of second quadrant, it is a second quadrant. For this second quadrant means output voltage is positive and output current is negative. So voltage is positive and output current is negative. That means power equal to V into I. That means positive into negative means negative. So power is negative. For this type B chopper or second quadrant choppers, output power is negative. So that means negative means it power flows from load to source. Power flows from load to source. Power flows from load to source. That means the type B chopper is suitable for braking purpose. Actually, for motoring purpose means power flows from source to load. That means it is reverse, load to source. Load to source means is nothing but braking. So type B choppers is suitable for regenerative braking. And this step up chopper operates in second quadrant. And step up chopper operates in second quadrant. Coming to type C chopper, two quadrant type A chopper. Type C chopper or two quadrant type A chopper. That means to get the type C chopper by type C chopper, we have to merging type A and type B choppers. Have to merge type A and type B choppers. That is, type C chopper will be obtained by merging type A and type B choppers. It is for type A, it is for type B. So by merging type A and type B, we can get the type C chopper. For this, two choppers, chopper 1, chopper 2 and diodes, two diodes, diode 1, diode 2. This is the load, this is the supply voltage. For this power, for this first quadrant, power is positive. For this second quadrant, power is negative. That means this type C chopper works as in this type C chopper, the power is both positive and as well as negative. Both positive and power is both positive and as well as negative. Power can be positive as well as negative. That means it flows both the direction. The power flows both the direction. That means source to load and load to source. So the power flows from both the directions. That means so it can be suitable for both motoring and braking applications. That means it type C chopper suitable for both motoring and braking applications. Next chopper, type D chopper. Type D chopper are two quadrant type B chopper. Type D chopper are two quadrant type B chopper. Type B chopper. That means for this first quadrant and fourth quadrant. For this first quadrant, power is both positive. V0 is positive, I0 is positive. So that is positive. For fourth quadrant, current is positive, voltage negative. That means power is negative. Positive into negative means negative, negative. That means power is both positive and negative. So output power is both positive and as well as negative, and power flows from source to load and load to source. That means power flows in both directions. And type D chopper is suitable for power flows from both directions, means it is suitable for both motoring and regenerative braking applications. Both motoring and braking applications. Next, coming to class E or type E choppers. This is nothing but four quadrant chopper. This can be obtained by merging either two type C or two type D choppers. This can be obtained by merging either two type C or two type D chopper. That is nothing but four quadrant. It is V0, it is I0. This is the four quadrant chopper. That is nothing but type E chopper. It permits both motoring and motoring and braking in both the directions. Both motoring and braking in both the direction of rotations. Okay, this is a type E chopper. Okay friends, thank you. In next video we will discuss remaining topics of electrical specialization. Okay, thank you.